Hello everyone, welcome back to my channel Ordinary Data Scientist, where we talk about data science. So friends, as I said in the beginning of the chapter that we'll pick few problem statement and we'll solve it in the Microsoft Excel, because Microsoft Excel has some inbuilt function which we can apply to quickly calculate few things. Okay, and I have already prepared an Excel tutorial. The link is given in the description. Please go through that tutorial if you are not very familiar with the Excel, because I covered a couple of interesting areas like how to apply filters, how to apply some formulas, and few other important topics in that tutorial. Okay, the first problem statement that we have is the Canada unemployment rate, where we have the 60 data points. As you can see, we have 60. I'll select from here. You will see there are 60 data points, and we want to find the central tendency of this data, like mean, median, mode. And this is ungrouped data. Towards the end of the chapter, we saw that there is the group data also, and there is a formulas written how to find mean, median, mode of the group data. So I'm not doing the analysis on the group data. I just copy pasted the results from the book. I want to show you that how different the values of group data are from the ungrouped data. Okay, so this is the data, and this is certainly by year, like it will be, let's say 1960, 1961, 1962, like that, but as we try to find the mean, median, mode, the central tendency of the data, we have to do, the first thing we have to do is that we need to sort the data by your ascending to descending. Do this, and you see I have the data in the ascending order, right? Like 2.3 to 12. So let's try to calculate the mean. Mean will be sum of all x divided by capital N. So let's say sum of all x divided by your 60. So mean is 6.85, which is good. Now median is your middle point. Now here if you see n is equal to 60, right? So it's a even number. So we remember that if it is even number, then it will be average of your middle point, which is 30th and 31st data point, right? So let's take it out. Average of 30th and 31st. So 30th and 31st. So people, you might see here 31 and 32. I'm selecting 31, 32 because the header, I have a header here. So 31st will have the 30th data point, 32nd will have the 31st data point. Similarly, if you see the last data point is 61. Okay, so select this data point and you get the average of these two, 7.05. Okay, mode is nothing but the highest occurred value. So here in the data, if you see which is the highest occurrence, you can go and manually check that what are the highest occurrence, but as we are doing in Excel, we will try to do it smartly. We'll use a count function, count if function. Again, you can go through my Excel tutorial and can understand this function. So we'll try to count of, let's say, 2.3 in this entire column. Okay, we'll copy this formula and paste it. So we see that this data point has twice occurrence. Few data points had 3 occurrence, like 7.5, 7.5 and 7.6 has 3 times occurrence. I'll just highlight it. So far this is the highest number of occurrence that I have seen, 3 occurrence. Yeah, so 7.1, 7.5 and 7.6, 7.1, 7.5 and 7.6. so this is definitely a multi-modal data where we have more than one mode. Okay, so this is the results on the ungrouped data. You can compare with the group data that very close, like 6.93, 6.85, very close. A mode here is just 8, where here we have multimodal, right? So this is the mean, median, mode on an ungrouped data. Now people, I have taken one more example from the book, which is 3.2, where I have the top food and drugs stores from United States and their revenue. Now I need to find a couple of things, their range, deviation, population variation, and all those things. Okay, so let's calculate that. The first thing I did that, I just copy pasted the data in an editable mode. So I copy pasted this from this image. Okay, so as you can see, the data is already in a descending order, but if you want, you can convert this into ascending order also. Now let's try to find the range. Range will be your max minus mean, right? So here the range will be your max, which is this one, minus your mean. So the range is around $58 billion. Okay, the question number 1. Now question number 2 or B says that find the mean absolute deviation. Okay, we need to find the mean absolute deviation. So let's take any table. Let me take this one. The first thing we need to find is that what is the mean of this data, right, which is mu, right? So mean will be your average of this data points, which is 33.04. Now if I copy this one, it will become 36, and if I copy this one again, it will become 39. So I again spoke this in length how to fix this this shell reference in the Excel tutorial. You might like to see that tutorial to understand why we need to fix the reference using the dollar sign. Okay, so here I have mean for this entire range. Now I'll try to calculate the deviation. Okay, so deviation, as you remember, x minus mu. So I'm calculating the deviation x minus mu. So I calculate the deviation from the mean. So this is like minus 25, so this is positive 33. So this is your deviation, and then I will do the absolute of this data points. So I'll apply absolute of all those data points. Okay, now mean absolute deviation is nothing but your sum of this entire thing, right, divided by your data point. So data point 1, 2, 3, 4, 5, 6, 7, 8. So mean absolute deviation is 16.33. Let's go to problem statement 3, which says that find the population standard deviation and variance. So we'll find both together. If you remember, the variance is your square of, I'll just try to write in plain English, square of your x minus mu, x minus mu square divided by n. X minus mu, you do all this sigma divided by n. Okay, we'll try to calculate that now. So let me copy this entire thing from here, and let's calculate the square of deviation x minus mu. So this is nothing but this into this. So the sum of deviation and variance will be your sum of deviation, entire sum, okay, divided by n, 331.06. Very fair. I'll just do the border all and convert this into decimal place. Yeah, so this is your variance, and your standard deviation will be square root of variance, 18.9. So standard deviation and your variance. Okay, the next problem statement is your finding the interquartile range. Now interquartile range, people, is finding all the Q's, right? So let's try to find all the Q's like Q1, Q2 and Q3. Okay, now let me try to make a table here like Q1, Q2 and Q3, the Pn, and then we'll calculate the I, and then we will find the data point. Now for Q1, the P is 25, Q2 50, and this is 75. N is always 8. I have the 8 data points, these 8 data points. Now for I, if you remember the formula, I is your P divided by 100 into N. So I write like this. 2, I've copied the formula below. So here the I is equal to this into this divided by 100. Now people, if you remember, I is a whole number, so that means the point will be average of second and third data point. Similarly here it will be average of fourth and fifth data point, and this will be average of sixth and seventh data point. Okay, now let's try to calculate the value. Value will be average of, let me write it, average of second and third. So as this is ascending order, I will go from top to bottom. If you haven't sorted the data, I'll request that you should go from bottom to top. Okay, so second and third. Similarly, this will be your average of fourth and fifth. So this is your fourth and this is your fifth, and this will be average of your sixth and seventh. So this is sixth and this is seventh. Okay, so this is average of second and third. This is average of your fourth and fifth, and this is your average of your sixth and seventh. Okay, so people, what was the formula of IQR? IQR is equal to Q3 minus Q1, right? So Q3 minus Q1. This is your interquartile range, is $27 billion, right? Good. Now let's go one step ahead and let's try to find the box and whisker plot also. So for box and whisker plot, we need to, if you remember people, we need to find the inner fences. So inner fences, the left extreme x1, let's say x1 was, what was the formula? X1 is equal to Q1 minus 1.5 times your IQR. So this will be your x1. The left hand side will be your Q1 minus 1.5 into your IQR is 27. Yeah, and x2, the right hand side fence will be this one. Yeah, so this is your Q3, yeah, plus 1.5 times your IQR, 86.2 to minus 22.2, and then you have the median. Median is the central data point 31, and you have the 25th and 75%. So you can plot the box whisker plot also. Okay, I'll try to solve here. Z score for Walgreen. So Z score for Walgreen. So if you remember, Z was x minus your mu divided by sigma. You want to convert the distance into sigma times. Okay, so for Walgreens, x is the Walgreen minus your mu, the average, divided by sigma. Now sigma I calculated here, sigma is 18. So this is your Z score for Walgreens, right? 7.79. Okay, Z score for Walgreen. Now coefficient of variance, if you remember people, coefficient of variance. So coefficient variance was equal to your sigma divided by mu into 100. So let's convert sigma divided by mu. I can take any reference into 100. So there is like 55.06. So that's how I can do all the calculation with the inbuilt function and can calculate the central tendencies. Okay, Let's take another example of empirical and Chebyshev theorem. Okay, time needed to assemble a particular piece of furniture with experience is normally distributed. Good, very good. It's a normal distribution. That's a good thing. And with the mean time, mean means your average is 43 minutes. If 68% of the assembly lines are between 40 to 46 minutes. Okay, now let me plot a normal distribution curve here. Okay, now if this is the central point, we remember that, I'll come back here, we remember that let's say sigma, this is your 2 sigma and this is your 3 sigma, you know. So from this point to this point, probably I'll go here one step, this point it will be 68% data points. Similarly 2 sigma to 2 sigma, I'll make some other color, merge center, will be your 95% data point. And similarly 3 sigma to your 3 sigma, I'll make another color, let's say green, it will be your 99.7% data point. Okay, now the problem statement says that 68% of the assembly times are between 40 to 46. That means we are talking about, you know, we are talking about your this area from sigma to minus sigma, right? This area, the yellowish area. Now I know this range is mu minus sigma to your mu plus sigma, right? Mu minus sigma to mu plus sigma. This is the range, and this range says that this is 40 to 46. So that means if I bring it here and if I write this is your 40 and this is your 46 and mu is your 43, can you tell me what is sigma? Sigma is equal to 3, because 43 minus 3 will be 40 and 43 plus 3 will give you 46. So that means sigma is equal to 3. Okay? Similarly, suppose that 99.7 of the assembly times are between 35 to 51. Now 99.7 is your 3 sigma, is between 35 to 51. So again mu minus 3 sigma is your 35 and mu plus 3 sigma is equal to 51 and your mu is equal to 43. So can you calculate what is this? So 3 sigma is equal to 35 minus 3 sigma from this equation. If I calculate, it will be mu 43 minus 35 and then divide by 3. And if I calculate from here, okay, if I calculate from here, sigma will be equal to your 51, you know, minus mu 43 and then divide by 3. You see the values come same. What will the value of standard deviation be now? Okay, suppose the time needed to assemble another piece of furniture is not normally distributed. What will the value of the suppose the time needed to assemble another piece of furniture is not normally distributed. So very important that now it's not normal distribution. Okay, not normal distribution. Now the assembly time, mean is equal to 28 minutes. What is the value of standard deviation if at least 77% of the assembly times fall between 24 to 34 minutes? So now we will apply the Chebyshev theorem, right? It says that at least 1 minus 1 divided by k square, you know, values will fall between mu minus k sigma to mu plus k sigma. This is the statement, right? So this is the statement from Chebyshev theorem. So let's quickly draw kind of any curve. So this, if this is the curve, let's say this is your central data point, which is your mu average. Can I find a range k to k sigma, and this range gives me around 77% data point. Okay, 77% data points fall under this. Can I find that? And if I find this kind of values, can I say that this will be your 24 and this data point will be your 32, because 77% data should fall under this range, 24 to 32. Yeah, now let's solve it. So the first thing that we need to solve is people to find the value of k, because we have this information that 77% data points fall under this region, and we know that 1 minus 1 by k square is the percentage values, right? So we'll solve this. Let's say 1 minus 1 by k square is equal to your 0.77, that is percentage. Now if I solve this equation, 1 by k square is equal to your 1 minus 0.77. So your k square is equal to 1 divided by 0.23, right? So k is equal to your square root of this step, right? 2.08. So that's how I got the value of k. Now if I consider the left one is mu minus k sigma, which is 24 here, and right hand side is mu plus k sigma, which is 32 here. So if I solve this equation here, I will get that sigma is equal to mu, which is your 28 minus 24 divided by k. Here if I solve this, it will be 32 minus mu divided by k, 1.93. So that's how I'll get the value of sigma using the Chebyshev theorem. Okay, so people, I went little slow for this video because I just wanted to go a little bit into the formulas, explain the formulas, how to apply some ready-made function in Excel, and try to answer these problems. Okay, so I'll request that you also practice the problem statement using your calculator or using Excel. If you are a student, definitely you should use the calculator, but if you are professional, you can use the Excel also. Okay, so I'll take a pause here. Please revise the all the functions, and I'll meet you in the next chapter. Thank you.